Have you ever wondered how computers in an office or across the globe connect and communicate? Well, it's not magic, but the fascinating science of network topologies that makes this possible. Think of network topologies as the blueprint or architecture that helps computers and other devices transmit data efficiently. In the realm of network topologies, there are several types, each with its own unique set of characteristics. These include two-tier and three-tier topologies, which are commonly used in local area networks. Then we have spine-leaf topologies, a popular choice in data centers. We also delve into wide area networks or DWAN, small office, home office or SOHO topologies, and the ever-evolving on-premise and cloud topologies. Understanding these topologies and how they work is key to ensuring smooth and efficient data communication across networks. So buckle up for an exciting journey into the intricate world of network topologies. Join us as we delve into the fascinating world of network topologies. Picture your local supermarket. Now, imagine it as a network. That's essentially a two-tier topology. In the world of networking, the term topology refers to the layout or structure of a network. Two-tier and three-tier topologies are two commonly used designs in network architecture. Let's start with the two-tier topology. Think of it as a supermarket where the checkout counters represent the access layer that connects to the customer, and the storage room represents the core layer which houses all the goods. In network terms, the access layer connects users to the network, while the core layer is where all the major network connections happen, like the supermarket's storage room. It's a straightforward and cost-effective setup, making it suitable for small to medium-sized networks. However, it's not without its drawbacks. For instance, scalability can be a challenge. As the network grows, the core layer can become a bottleneck, limiting the overall performance of the network. Now, let's move to the three-tier topology. This is like adding a manager's office to our supermarket analogy, which oversees both the checkout counters and the storage room. In network terms, this is the distribution layer. It acts as a liaison between the core and access layers, managing communication between them. This design provides greater scalability and flexibility, making it ideal for larger networks. But just like with everything else, there are also downsides. A three-tier topology is more complex and can be more expensive to implement and manage than a two-tier topology. So, whether it's a small business or a big corporation, these topologies help keep things connected and running smoothly. They each have their own strengths and weaknesses, and the choice between them depends on the specific needs and resources of the network in question. It's a bit like choosing the right layout for a supermarket. You wouldn't want to use a small corner store layout for a huge hypermarket, and vice versa. The same principle applies to choosing the right network topology. So, whether it's a small business or a big corporation, these topologies help keep things connected and running smoothly. From your home office to the wide-open internet, networking takes different shapes and forms. Let's dive into the world of spine-leaf, WAN, and SOHO topologies to get a better understanding of how these networks function. Starting with the spine-leaf topology, it's a design that's been gaining popularity due to its scalability and efficiency. In this design, all devices are interconnected, meaning there's no hierarchy. This allows for high bandwidth, low latency connectivity, making it ideal for data centers. But it's not all sunshine and rainbows. The cost of implementing and maintaining a spine-leaf network can be quite high due to the sheer number of connections involved. Next, we have W1 or wide area network topology. As the name suggests, this network spans a large geographical area, like cities, states, or even countries. It's used by businesses and governments to communicate and share data over long distances. The benefit of a WAN is its vast reach. However, it comes with its challenges, such as the complexity of setup, high operational costs, and potential security vulnerabilities. Lastly, we come to the SOHO, or small office, home office topology. This is a common network setup for small businesses and home offices. It's typically a simple network that includes a few computers, a printer, maybe a fax machine, all connected to the internet via a router. The upside to SOHO is its simplicity and low cost. Yet, it might lack the robust security features of larger networks and can be limited in terms of scalability. In essence, each of these topologies has its place. Spine leaf offers high speed and efficiency, perfect for data centers. WANs provide wide geographical coverage, essential for multinational businesses. And SOHO networks offer simplicity and cost-effectiveness, ideal for small businesses and home offices. These topologies ensure that whether you're working from home or a multinational company, you're always connected. Ever wondered how your data travels when you save it to the cloud or access it on your local server? Let's dive into the intriguing world of on-premise and cloud topologies. On-premise topology, as the name suggests, refers to network infrastructures that are physically located within the organization's premises. Picture a room full of servers, cables, and network devices, all humming away, working together to ensure your data is accessible when you need it. That's on-premise topology for you. It offers complete control over your data and network, providing a higher level of security since all data remains within the organization's physical boundaries. However, it does come with its own set of challenges. The costs of maintaining and upgrading hardware, software, and security measures can be substantial. Also, the physical proximity of the network components means that a single disaster could potentially wipe out all your data. On the other hand, we have cloud topologies. Imagine if that room full of servers and cables was located somewhere else, managed by a team of specialists, and you could access your data anytime, from anywhere. That's the beauty of cloud topology. Here, data is stored in the cloud, which is essentially a network of servers located in data centers around the world. The advantages of cloud topology are manifold. It offers scalability, flexibility, and cost-effectiveness as you only pay for what you use. Plus, with data backed up in various locations, the risk of data loss is significantly reduced. However, since data is stored outside the organization's physical boundaries, there can be concerns about data privacy and security. In essence, both on-premise and cloud topologies have their own unique set of benefits and drawbacks. The choice between the two largely depends on the specific requirements and constraints of the organization. So, whether you're saving a document on your computer or on the cloud, it's all about network topologies. It's not just about invisible data floating around. Sometimes it's about the physical connections too. Let's dive into the world of physical interfaces and cabling types. These are the tangible links that ensure smooth data flow across network topologies. They come in different types and play unique roles in various topologies. Starting with the physical interfaces, these are the ports where the cables plug into your devices. They range from the common RJ45 used for Ethernet connections to the high-speed fiber-optic interfaces. Each has its own unique design and is optimized for specific types of data transmission. Now, onto the cables. There are several types, including coaxial, twisted pair, and fiber-optic cables. Coaxial cables, often used in cable TV and internet services, have a single copper conductor at their center. Twisted pair cables, commonly used in Ethernet networks, come in two types: shielded and unshielded. Shielded twisted pair cables have a protective shield to reduce electromagnetic interference, while unshielded twisted pair cables do not. Fiber optic cables transmit data as light pulses, making them capable of high-speed, high-capacity data transmission over long distances. They're often used in backbone network lines and high-speed data transfer scenarios. But these physical connections aren't without their challenges. For instance, collisions can occur when two devices attempt to send data simultaneously. Errors can happen due to issues like faulty cables or interference. Duplex mismatches, where one device is set to full duplex and another to half duplex, can cause slow network performance. And speed can be a concern when the network cabling doesn't support the desired data transfer rate. Overcoming these challenges requires understanding the role of each cable and interface in your network topology and troubleshooting issues as they arise. It may seem a little daunting, but with a bit of practice, you'll become a pro at managing your network's physical connections. So next time you see a network cable, remember it's not just a wire, it's a vital part of the network topology. So, we've journeyed through the intricate world of network topologies, learning how our digital world connects. We've unpacked the structure of 2-tier and 3-tier topologies, understanding their role in creating hierarchical network designs. We've also explored the complexities of spine leaf, YN, and SOHO topologies, each having a unique function in different network environments. The discussion didn't stop there. We delved into on-premise and cloud topologies, revealing how they are revolutionizing the way organizations run their IT infrastructure. And let's not forget our deep dive into the physical side of networking, where we examined the various types of interfaces and cabling. We learned about their potential issues, such as collisions, errors, mismatched duplex, and speed, which can all impact network performance. So as we wrap up, let's take a moment to appreciate the backbone of our digital age, these diverse network topologies. Remember, every click, every file sent, every web page loaded, it's all thanks to these network topologies. Until next time, keep exploring the digital universe.